So here's an answer key for the May 2012 Paper 2 Time Zone 1, which was written in last year's standard level mathematics exam. This is a calculator allowed version. The first question is sequences. In order to find the value of d in a sequence, we just need to subtract two terms. So d is term 2 minus term 1, term 3 minus term 2, which is 40 minus 36, or 4. It's how much you have to go add to get from one term to the next term. In order to find term number 8, we can use the formula first term plus n minus 1 times d, which would be 36 plus 8 minus 1 times 4, or 36 plus 28, to get 64. And we can check that just by adding 4 each time and making sure that we actually do get up to that term. 1, 2, 3, 4, 5, 6, 7, 8. In order to find the sum of the terms, you can do n over 2, 2a plus n minus 1 d. So we want n over 2, 2 times the first term, plus number of terms minus 1 times the distance, 4. So that would be half n 72 plus 4n minus 4, expanding the 4 into the brackets, to give 68 plus 4n times n over 2. And if we expand that out, we get 34n plus 2n squared. So in order to find the value of S14, I'm just going to plug in 14 for n. So 34 times 14 plus 2 14 squared. The sum of the first 14 terms. $868. Second question is the quadratics question. In order to find the vertex, we want to write this in vertex form. Which is kind of tricky because there's a leading coefficient. So if I have a graphing calculator, and in this case I do, in order to save time, what I'll do is just graph that function. See if I can make this smaller. There we go. Okay, so I'll graph 2x squared minus 8x minus 9. I'll just take a look and see if I can find the minimum. Maybe go from negative 20 to 20. There it is. So if I second calculate the minimum from a left bound to a right bound, then I get 2 negative 17. Okay, from the graph. So in order to write the function in terms of completed the square form, all I need to know is that the vertex is h and k. So I can just plug in 2 for h and 17 for k. If I'm not really sure if that works, what I'll do is just type it into my calculator and make sure I get the same picture. Maybe I'll make this a little bit darker so that you can see it. The first graph, second graph, they match, so I must be right. Now to find out where the equation equals 0, that's just trying to find the zeros of the graph. So where is the graph equal to 0? I'm just going to calculate the zeros. And that's kind of hard because I need left bound, right bound. So what I'm going to do to make it easier is I'm just going to say equals 0. And then I can graph and calculate the intersections. So first graph, second graph I want 0. And I get negative 0.915. I'm going to do the same thing again, so I can calculate intersect between the 0 curve and the graph. And I get 4.92. So always write your answer with 3 significant figures. There we go. Okay, in order to find a determinant of a matrix, what you want to do is just take your diagonal, multiply them together, minus the other diagonal, 2x times x squared. And I get x minus 2x cubed. To find the determinant of a 3 by 3 matrix, however, I need my graphing calculator. So I'm going to quit. I'll make a matrix. I'll edit my matrix A, and I'm going to make it 3 by 3. And I'll type in the values. 2, 3, negative 1, 4, 2, 0, 1, 5, 1. So now I'll quit and I'll actually go to my catalog, just go down to the D section and choose determinant, and then I'll go back to my matrix and choose matrix A. Calculate the determinant of A, I get negative 26. For C, find the value for which determinant M equals determinant N. What that means is that x squared minus 2x cubed should equal negative 26. In order to do that, I can just graph it. So I want to know when is x squared minus 2x cubed equal to negative 26. So when are those two graphs the same? Well, where do they intersect? So I want to calculate the intersection, enter, enter, enter. And there it is, when x is 2.53. Okay, so basically I'm just taking those two graphs and finding out where they cross. I don't care about the y value, just the x value. And keeping 3 sig figs. Okay, so statistics problem. So this is a normal distribution. So I've got a graph like this with a mean at 117 and a standard deviation of 5. So that means when I go up 5 and down 5, that's going to be 68% of the graph right there. So I want to find the probability that the child is taller than 122 centimeters. Here's my graph. 117 is right here. If I go up 5, 122, then I'm 1 standard deviation away. And I'm just a little bit bigger than that. So I want to know this region of the graph here. It's probably a very small percentage. Let's see if I can estimate this. I know I've got 50% here, 34% here, so that's 84. I'm looking at about 16% of the graph. Oops. So in order to find out the probability that x is bigger than 122.5, I can use my normal distribution. So go to the catalog, down to normal. I want normal CDF. So this is from 122.5 to infinity with a mean of 117 and a standard deviation of 5. So 14%. That's pretty close to the 16% I was thinking before. So let's say 3 sig figs would be 13.6%. So I'm just going to say what I did. I did normal CDF of 122.5 to infinity. It's a really, really big number with a mean of 117 and a standard deviation of 5. Now B, find the probability that the child is shorter. Okay, you're given the probability that the child is shorter than k centimeters is 0.65. Find the value of k, so that's going to be the inverse normal. So let's see, what does that function look like? Go back to the catalog. Inverse normal of 0.65 if the mean is 117 and the standard deviation is 5. So it's 118.9, or 3 sig figs would be 119. Inverse normal 119, inverse normal of 0.65 with a standard deviation of mean of 117, standard deviation of 5, gives an answer of 119. And I'm just going to double check that backwards again. So go second enter. I want the normal CDF, and I want it to be shorter. So I want to go from negative infinity to 119, or 118.9 if I want to be more precise. So that's the kids that are shorter than 119 centimeters. And what I want is I want to get an answer of 65%. So hopefully this works. Yeah, looks good. So question number 5, another matrix question. It's unusual. Find the value of P and Q. We're given M and we're given the inverse. So I guess the key to this one is the fact that if you take the inverse and then inverse it again, you get M. So all we need to do is now go back to our matrices. Let's edit that first one again. And I'm going to put in 3, -5, 4, -1, 1, 0, 1, -3, 2. Now I'm going to go to my catalog, and I want to, oh, no, I don't even need my catalog. I want to take my matrix A and invert it, so do it to the power of -1. Technically, I still need that 1/2 in the front, so I'll do 1/2 of A and invert that. And there's the matrix. It looks like all the other numbers line up with M's matrix. So I can read from that P is 1 and Q is 2. So in order to solve a system of linear equations, all I need to do is recognize that this is actually a solution to a matrix. So all these numbers here represent the numbers that are in M's matrix. So this is just saying that Mx equals 7 to negative 3. Or we could say it as, let's see, what was M again? This thing in my calculator. 1, negative 1, negative 2. 1, 1, negative 2. And 1, 2, negative 1. Times xyz equals 7 to negative 3. So if I want to solve this equation for xyz, what I need to do is I need to move the matrix over to the other side. And the way to do this is using the inverse matrix. The trouble with matrices is that the order is important. So if I want to do this, what I need to do is I need to take M inverse on both sides. And M inverse and M will cancel each other out. So if I put M inverse at the front on both sides, then the matrix will cancel off. So this one will be gone. We'll just get the identity. So xyz is equal to M inverse times 7 to negative 3. So then on my graphing calculator, I'll just take M inverse, which is 1/2 A. Okay, that's given in the question. And let's see, I guess I need to make another matrix. So back to my matrices. I'll edit B and make it a 1/3 matrix. Oops, 3/1. There it is. 7 to negative 3. So now I'll take 1/2 A times B. And there it is. I can take that and make it a fraction. So my answer is negative 1/2, negative 5/2, negative 5/2. So x is negative 1/2, y is negative 5/2, and z is negative 5/2. Not really sure about that answer perhaps, so I'm just going to go back and take my equations, and if I've got time at the end of the exam, I'll just plug it in. So what I want is 1x minus 1y minus 2z. I want this to be 7. As long as negative 0.5 is stored as x, negative 2.5 is stored as y, and negative 2.5 is stored as z. So let's see if that equation will equal 7. Yay! Okay, now is x plus y minus 2z equal to negative 2? Oh, positive 2. Yes, it does work. And is x plus qy minus z equal to negative 3? Yay! I know my answer is right. Ooh, binomial theorem. So in order to expand 2x cubed plus b over x to the power of 8, I can use my Pascal's triangle. Woohoo! I just need the row that has an 8 in it. So 1, 4, 6, 4, 1. You can also do this using combinatorics, but usually they're not going to ask you to go up to much more than 10. so it doesn't take too long to make this. So those numbers are going to be the coefficients of the expansion. And it looks like I only need to include 2 terms for now. And then what I do is I just take the first term, 2x cubed. That's going to come on every term. And I'm going to start with 8 of them. And the next term is going to have 7, and then 6 and 5 and 4 and so forth. And what happens with the b over x term is that I start with 0 of them, b over x, and they grow. 1 on the second term, 2 on the third term, and so on and so forth. If I add all those terms together, then I get the full expansion. So I know that this first term here must be 256 x to the 24. That's not going to help me find b since b cancels off anyways. But the second term, if I match up these two, then I should be able to find b. So I'm just going to say that 8 times 2x cubed to the power of 7 times b over x has to be 3072 x to the power of 10. Sorry, x to the power of 20. That's better. Okay, so 2 to the power of 7 is 128. So in here I get 128 x to the 21. And remember, b over x can also be written as bx to the negative 1. So that when I put those two x's together, 21 minus 1 will give me 20 x's. 128 times 8 is 1024. So the x's will cancel. If I divide both sides by 1024, I should get my b. Looks like it's going to be 3 or something like that. 3072 divided by 1024 is 3. Now to find the value of k. That's part B. K is when you have a constant term for x. So let's see, when is that going to happen? So my first term is going to have, I'm going to keep writing this thing out here. My next term will have a 28 at the front. It's going to have 2x cubed to the power of 6, and I'll have b over x to the power of 2. So altogether my x's are going to be 18 minus 2 is 16. So the x's didn't cancel out for that term. Next one is 56. 2x cubed to the power of 5. And b over x will be 3. So that'll be 15 minus 3 is 12. Nope, not that term either. Now I'm cheating and not looking at Pascal's triangle, because I'm just trying to find the term where the x's cancel. So here I've got x12 minus 4, which will be x to the power of 8. So that doesn't work either. Next term we'll have x to the power of 9 minus 5. Nope. Next one, x to the power of 6 minus 6. There it is. This is the constant, because my x to the power of 6 and 1 over x to the power of 6 cancel, so there'll be no more x's. So now I can figure out what this number is here by looking back at Pascal's triangle. So let's see, I've got 1, 8, 28, 56, 70, 56, 28. 70, 56, 28. So my term is 28, 2x cubed to the power of 2, b over x to the power of 6. 28, 2x cubed to the power of 2, b over x to the power of 6. If I expand that out, the 2 goes into the brackets. I get 4x to the power of 6, b to the power of 6, x to the negative 6. So those two x's cancel. So I get 28 times 4, or 112, b to the power of 6. But since b is 3 from the previous, 112 times 3 to the power of 6 gives me 81648. I'm not sure if they want 3 sig figs for that one. In that case, you would have to write it as 8.16 times 10 to the power of 4. I'm guessing they probably only want 3 sig figs for decimal answers. I'm guessing that you can keep that as an exact answer. Okay, so the probability question. Probability of obtaining tails on a biased coin is 0.57. The coin is tossed 10 times. So this is a repeated experiment. And you're going to use a binomial. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 coin tosses. You want to get at least 4 tails. So that would mean 4 tails, or 5 tails, or 6 tails, all the way up to 10 tails. So the chance of getting 4 tails would be, well, that means I have to have tails, which is 0.57 chance, happening 4 times. And that would also mean that the rest of the tosses would have to be heads. So I'd have to get 4 tails and 6 heads. So the chance of getting heads is the opposite of 0.57, which is 0.43. I'd have to have that 6 times. And the other trouble is that it might not be tail, tail to tail, head, 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 head. It could be head, tail, head, tail, head, tail, head, tail, and then the rest heads. So the order matters. Out of all 10, I want to choose 4 of them to be heads. So that's how many ways I can get, I want to choose 4 tails. That's how many ways I can get exactly 4 tails. Plus 5 tails. And I'm going to go all the way up to 10. And I add all the terms. That takes a while. So instead I can use the cumulative binomial. So let's see if I can find that catalog binomial CDF. So the arguments are NPX, so the number of trials, the probability that you're looking for, and the number that you want. Oh, but the problem is that this is going to go from 0 up to that number, and I want from that number up to 10. So I find binomial CDF is not actually that helpful sometimes. Oh, I just lost my calculator. Get it back. So I find binomial PDF is much easier to use. Let me go and get that one. Binomial PDF. That finds the exact probability. So I could go 10 probability 4, and that would give me the chance of having exactly 4. If I want to add up a whole bunch of probabilities, what I can do is I can use my squiggly brackets and go 4, 5, 6, 7, 8, 9, 10. And that'll give me all the possibilities from 4 to 10. Pretty much as, oh, I forgot a 10 in the first number. Can't all be zeros. Okay, so NPX. Okay, and that'll give me a list of the probabilities for 4, 5, 6, 7, 8, 9, 10. All I have to do is sum those all together. So I go down, find my sum, and sum in all those. And I get 92% chance. So basically I'm doing sum of binomial PDF, number of trials, probability that I'm looking for, and the numbers that I want, 4, 5, 6, all the way up to 10. And I get 91.9%. Again, if I'm not sure of my answer, I'll double check it another way. Let's see. At least 4 tails is the same as at most 3 tails. So I should be able to get the same answer by doing at most 3. Binomial CDF going from 10 all the way up to 3. That should give me the same answer. The opposite. So if I do 1 minus that answer, I get my 0.919. So the other way to do that is 1 minus at least, at most, 3 tails. Okay, so for B, how do you get the 4th tail on the 10th toss? What that means is I got 3 tails in 9 tosses, and then another tail. So out of 9 tosses, I want to choose 3 tails. The chance of tails is 0.57, it has to happen 3 times. Chance of heads is 0.43, has to happen 6 times. Okay, or I can go binomial PDF of, out of 9 tries, chance of tails, I want 3. Okay, and that should give me the same answer as 9, choose 3, 0.57 to the power of 3, 0.43 to the power of 6. Yes. Okay, so that's the chance of getting 3 tails in 9 tosses, and then I'll times that by 1 more tail. So that's a 0.056, so 5.61% chance. So my last one, so this is 3 tails in 9 tosses, and then 1 more tail. So another 0.57. Okay, now the long answers, the last half of the test. So this is a statistics problem. In order to find the values of P and Q, we can read them right off the graph. So you can see that you have 7 here for the first one. You've got 14 here for the second one. So P must be 17. 20's here. Q must be 11. So P is 17, Q is 11. Now, in order to find the median class, we want to know where does the middle term occur. So these are the different classes. And we want to know in which of these 7 classes is the middle term. So let's add up all these numbers. And you get 93. So half of that is the 46th or 47th term. So let's see, where is that going to happen? From the first 2, we have 21. Go up again to the next class, we'll get 38. And then I think the 46th term will happen in the class that has 20. Yeah, so the 46th, 47th term are in this class here. So the median class is from 75 to 85. The child was selected at random. Find the probability that the child takes less than 95 seconds to solve the puzzle. So that would be all of these kids on this part of the chart. So does it tell us how many children there are all together? We have 93 children. So the total is out of 93. And the number of them that are less than 95 seconds is 7 and 14, 17, 20, and 18. Total of 76 out of 93. That's simplest form. Now consider the class 45 to 55. What is the interval width? Well, the interval width is the distance from 45 to 55. So from 55 to 45 plus 1 is 10. What is the mid-interval value? What's the midpoint? That would be 55 plus 45 divided by 2, which is 50, the halfway point. Find the estimate for the mean. So to estimate the mean, we could just take the mid-interval values, multiply it by the number of people in that value, just add all those things together. So we got 60 times 14. I'm just going to plug that into my calculator. 50 times 7, 60 times 14, 70 times 17, 80 times 20, 90 times 18, 100 times 11, and 110 times 6. We'll divide that by the 93 students that we have, and the average is about 79.1, which is in our median class. So that's a pretty good sign. 79.1. Dividing it by the number of students gives me an average of about 79.1. Now let's see if I can use my stats to estimate the standard deviation. So there's my stats. I can edit a list, and I'll make the first one my mid-interval values. So 50, 60, 70, 80, 90, 100, 110. I'll make the second list my frequencies. Okay, now I'll calculate some one variable statistics for L1 and L2. Oh yes, my mean is 79.1. Great. That confirms the calculation I did before. My standard deviation, sigma x, is 16.4. See, my median is 80, which is in the median class from 75 to 85. Okay, now John assumes that t is normally distributed. Ooh. Uses this to estimate the probability that a child takes less than 95 seconds. So I know that the mean is about 79.1. And so I want to know, what's the chance that you take less than 95 seconds to solve the puzzle? So that's going to be the normal CDF from negative infinity all the way up to 95 for a sigma or mean of 79.1 and a sigma of 16.4. Let's go to catalog, normal distribution, cumulative from negative infinity to 95, mean of about 79.1 and sigma of about 16.4. It gives me about 83.4% chance. Okay, now for question 9, a trigonometry problem. To show that this is the case, I'm given this triangle. I want to show that p squared times all this is equal to 36. What might I do? Well, I see the cosine in here, so I'm thinking maybe cosine law? Let's try that. The cosine law says that c squared is a squared plus b squared, so it's like Pythagorean theorem with a little adjustment, minus 2ab cosine big C, where big C and little c have to be opposite each other. I'm using different letters than they use on the triangle. So 6 squared is 4p squared plus 5p squared minus 2 4p 5p cosine 0.7. So 36 is 16p squared plus 25p squared minus 40p squared cos 0.7. So I can add these two terms together. 16 plus 25, 41. Okay, I can't combine that with, I can't just put those two as 1p squared because the last term has a cosine 0.7 on it. So it's not a like term. But I can factor out the common factor of p squared. So in order to find p, I just plug this into my calculator. 36 divided by 41 minus 40 cosine 0.7. Gotta make sure my calculator is in radian mode. Otherwise this is not going to work. Yay, it is. Okay, and there's my p squared. So if I take the square root, I get p, 1.86. Now this picture here is related to the top picture, so I still have the same 4p here, 5p on this side, 6. Since this is on a circle, I also know that this side is 6. So it says write down the length of BD, and again, because they're both radius of a circle, BD is also 6. To find the angle ADB, this angle here, what do I do? Well, it looks like I'm going to use the sine law because I know an angle and a side across from it, and I want the other angle and side across from it. So sine of an angle divided by side across is equal to sine of this unknown angle divided by the side. And it's 4p, but I actually know what p is. So I can actually put that in as a number. So sine of ADB is equal to 4 times 1.86 times sine 0.7 divided by 6. So 4 times this answer. I'm keeping all the decimals so that I don't lose any information. Divided by 6 is, and then if I do inverse sine, I can get the angle. Ah, that's in radians. Okay, so the angle ADB is equal to 0.925 radians. I have no idea what that actually is. So let me just change it to degrees just to see if that makes sense. So if I did that again, sine inverse of 0.7988113073, I get 53 degrees. Does it look like about 53 degrees? Not at all. It looks obtuse. So maybe there is another answer. So on my All Students Take Calculus, I just found out that the angle is 53 degrees, but I looked at the picture and it looks obtuse. So I'm guessing that maybe it's in this quadrant where the reference angle is also 53 degrees. So if I do 180 minus 53, that gives me another answer, 126 degrees. Okay, which is the same as just doing pi. Where's my pi button? There it is. Minus the 0.925. So maybe I think that my angle is actually 2.22. Not 0.925 after all. Now to show that CDB is equal to 1.29 radians, that's this one right here, all I need to do is use the fact that their angles on a line. So that would be 180 degrees minus angle ADB. Or if I'm using radians, that's pi minus 2.22. This is another way for me to verify if I made a mistake with the other angle of sine. So let's see if I did that right. Pi minus 2.22 is 0.925. So that's not 1.29. CBD. Oh, wrong angle. That's 0.925. 0.925. It's this one here. 0.925. Sorry, angle CBD is actually this angle here. Now because this side and this side are the same, I have an isosceles triangle. So this one is also 0.925. So I can find out the third angle because they all have to add up to 180. So 180 is the same as pi. I do pi minus 0.925 minus 0.925. I should get that top angle. 1.29. Yay! So I'll take pi minus 0.925 minus 0.925, and I get 1.29. So in order to find the area of the shaded region, I can find the area of that part of the circle minus the area of the triangle. So I actually don't have a formula sheet on hand. I'm going to try to do this another way. The area of the circle is just the area of a whole circle, which is pi r squared, times whatever fraction of a whole circle I have. So my angle is 1.29 radians, but a whole circle is 2 pi radians. So if I take those numbers, I should get the area of the sector. So pi times 6 squared times 1.29 over 2 pi is 23.25. Then the area of the triangle it's not a right angle triangle, so there's not really an easy way to do this. To find the height, I know there's an easy formula for it. Let's see. To find the height of the triangle, I can use sine theta is equal to opposite over hypotenuse. That can give me the height. And cosine theta is equal to adjacent over hypotenuse. So that'll give me half of the base. Which is good because the area of the triangle is half of the base times the height. So I just need the height, which is 6 times sine of 0.925. And then times half of the base, which is 6 times cosine 0.925. And you have a formula for this in your formula book. You get 0.581. So now if I take those two away from each other, 23.248667777 minus that area, I get 22.7. Phew. And the last question. Okay, this is 2 ships moving. At noon, ship A was 15 kilometers due north, and ship B was moving east at 11 kilometers per hour. So that's 12 o'clock. At 1 o'clock, since ship A is moving 15 kilometers per hour, ship A is going to be 15 kilometers below where it is right now. It's going to be at the origin. And B is moving 11 kilometers per hour. So after 1 hour, it's going to be 11 kilometers over. So the total distance between 0 and 11 is 11 kilometers. At 2 o'clock, ship B is going to have moved another 11 kilometers, so it's going to be at 22. And ship A will have moved another 15 kilometers down, so it'll be at negative 15. So the total distance between the ships at that point is just 22 squared plus 15 squared, square rooted. So 15 squared, 22 squared is 26.6 kilometers. Now we can find a general formula for the distance between the ships from 0 to 4 hours. So where will ship A be at? So the distance is the square root of where A is squared plus where B is squared. So where is A? Well, when t is 1, A is at 0. When t is 0, A is at 15. So let's see if I can make a little chart here. Where is A at? When t is 1, A is at 15. T is 2, sorry, when t is 0, A is at 15. When t is 1 o'clock, A is at 0. When t is 2 o'clock, A is at negative 15. 3 o'clock is negative 30. So can I find some expression relating t and A? Minus 15t. That works. Now for B, when t is 0, B is at 0. T is 1, B is at 11. T is 2, B is at 22. So I just take 11 times t. So now if I expand this, I'm going to FOIL. So I'll get 225, 2 times 15 times 15, 450, 450t, plus 225t squared. FOIL the first bracket, and then this second one I can just multiply 11 squared and get 121. So now I combine my like terms. So 225 and 121 is 346. So hopefully that's what they have. 346, 450, 255. Yay! So sketch a graph of that. Well, I can use my graphing calculator. That's fantastic. So square root 346x squared minus 450x plus 225. And my window, let's see, x is going from 0 to 4. That's the time. My y is the distance. I already know the distance at 1 o'clock is 26 kilometers. So I know that I need to go at least up to 26. Maybe I'll go up to 50 and see what it looks like. Ah, it looks like it fits pretty well. Technically, I should probably go a little bit higher so that I can see at least where it is when x is 4. There we go. So it starts somewhere, goes down a bit, and then comes up again from 0 to 4. Now, due to poor weather, the ship can only see another ship if they are less than 8 kilometers apart. Explain why the ship cannot see the other ship between 0 and 4 o'clock, or 16 o'clock. So does this graph ever get less than 8 kilometers? Let's check out and see what the minimum separation is. So left bound, a little left of the minimum. So this is the distance between the ships. The y value is the distance between the ships. So if the distance between the ships is not below 8, then I know I'm good. The minimum value is 8.87. So 0.89, 8.87. This value here is 0.89, 8.87. The minimum distance is 8.87 kilometers. So since this is greater than 8 kilometers, the ships can't see each other. So always make sure you include an explanation and words when it says explain. Okay, and that's it for paper 2.